Example 1. Explain why CH3 thrice C plus is more stable than CH3 CH2 plus, and CH3 plus is the least stable cation. These are all carbocations. In the first case, your carbon with the positive charge is attached to 3 methyl groups. In the second case, we have the carbon with positive charge attached to only one methyl group. In the third case, we have the carbon with plus charge not attached to any carbon. There are two effects which can explain why this carbocation, which we can call as tertiary carbocation, because the carbon with the plus charge is attached to 3 carbon, is more stable than this carbocation, which is primary, is more stable than methyl carbocation. These two effects are, first of all, plus I effect or inductive effect. Methyl groups act as plus I groups. They release electrons, and therefore this carbon with the plus charge, because more electron density is surrounding it now, is more stable as compared to this carbon here. Because there is only one methyl group releasing electrons, it is not very stable. In this case, there is no methyl releasing electrons towards this carbon, and hence it is the least stable. The second concept that can be applied here is hyperconjugation. So, to write hyperconjugation forms, we require alpha hydrogen. Alpha hydrogens are these hydrogens which are present on the adjacent carbon. These carbons are called as alpha carbon, that is the carbons next to the C with a plus charge are called as alpha carbons, and all these hydrogens attached to these alpha carbons are called as alpha hydrogens. We can see here that there are 9 alpha hydrogens. So, we can write for this type of carbocation 10 hyperconjugation forms. 9 alpha hydrogens and plus this compound here, the original compound. So, we get 10 hyperconjugation forms total. More the number of hyperconjugation forms, more stable is that cation. Coming here, this is our alpha carbon, and therefore we can see that there are 3 alpha hydrogen plus the original compound. Therefore, 4 hyperconjugation forms can be written. Whereas when we come to methyl carbocation, there are no alpha hydrogens because there is no alpha carbon only, and therefore no hyperconjugation forms can be written here, and hence we say that tertiary, which has 9 alpha hydrogen, is more stable than primary having 3 alpha hydrogen as compared to methyl carbocation. So, the stability can be explained by plus I effect as well as hyperconjugation.